Imagine this. For centuries, people have known that our planet is round. But what if I told you that some still believe the Earth is flat? That's right. Members of the Flat Earth Society and even some celebrities like rapper B.O.B. and NBA player Kyrie Irving still hold on to this belief. So let's dive into the fascinating world of science and physics and explore how these principles would hold up, or not, on a flat Earth. Get ready for a mind-bending journey. Gravity fails. The idea that the Earth might be flat raises some important questions about the nature of gravity. According to James Davis, a geophysicist at Columbia University's Lamont Doherty Earth Observatory, it's unclear how gravity would work or even exist in such a world. This is significant because gravity plays a fundamental role in explaining a wide range of phenomena, both on Earth and in space. From the falling of an apple to the orbit of the moon around the Earth and the planets around the sun, gravity is a force that shapes our understanding of the universe. Without it, the laws of physics as we know them would be radically different. It's worth noting that the belief in a flat Earth comes with some pretty significant misconceptions about gravity. While flat Earth believers assume that gravity would pull straight down, there's actually no evidence to support this idea. In fact, our understanding of gravity suggests that it would pull towards the center of the disk. This means that gravity would only pull straight down at one point on the center of the disk, with increasingly horizontal tugs as you move away from the center. This would have some pretty bizarre effects on the world as we know it. For instance, all the water on the planet would be pulled towards the center of the disk, and trees and plants would grow at odd angles since they would develop in opposition to the pull of gravity. Clearly, a flat Earth would present some serious challenges to our understanding of the natural world. Solar problems. Another key challenge for the flat Earth model relates to the movement of the sun. In the scientifically supported model of the solar system, the Earth revolves around the sun because the sun is much more massive and has more gravity. However, the Earth doesn't fall into the sun because it is also moving in an orbit. This means that the sun's gravity isn't acting alone. The planet is also moving in a direction that is perpendicular to the star's gravitational pull, which helps generate a circular orbit around the sun. However, in the flat Earth model, the sun circles above the top side of the world like a carousel, providing warmth and light downwards like a desk lamp. This model doesn't suggest that the sun orbits the Earth, but without the linear perpendicular momentum that helps generate an orbit, it's unclear what force would keep the sun and moon hovering above the Earth and prevent them from crashing into it. According to James Davis, this presents a major challenge to the flat Earth model and calls into question the basic assumptions that underpin it. The difficulties of a flat Earth model extend to satellite technology as well. In such a world, it's likely that satellites would be impossible to launch and maintain in orbit. James Davis notes that this could have serious implications for society, as many important functions such as GPS rely on satellite technology. In fact, he says, he cannot even imagine how GPS would function on a flat Earth. Furthermore, if the sun and moon simply loop around one side of a flat Earth, it would be difficult to explain the changing of the seasons, eclipses, and other natural phenomena that we observe. Additionally, the sun would have to be significantly smaller than Earth in order to avoid burning up or colliding with our planet or the moon. However, we know that the sun is more than 100 times the diameter of the Earth, so this model simply doesn't hold up to scientific scrutiny. Removing heaven and Earth. Even if we set aside the issue of gravity, a flat Earth would present a range of other problems. For instance, the planet's magnetic field, which is generated deep within the Earth's solid core, would need to be replaced by something else. One possibility is a flat sheet of liquid metal. However, this would not rotate in a way that generates a magnetic field, which is crucial for protecting the planet from charged particles from the sun. Without a magnetic field, the atmosphere could be stripped away by these particles, as happened to Mars when it lost its magnetic field, and the air and oceans would escape into space. Additionally, tectonic plate movement and seismic activity rely on a spherical Earth. This is because only on a sphere do all the plates fit together in a sensible way, with movements on one side of the Earth affecting those on the other. On a flat Earth, none of this could be adequately explained. There would also need to be an explanation for what happens to plates at the edge of the world. It's possible that they might simply fall off, but this would pose a serious threat to the proposed wall that is supposed to prevent people from falling off the edge of the disc-shaped world. All in all, the idea of a flat Earth presents numerous scientific and practical challenges that cannot be easily overcome. Falling flat. It's a common misconception that many educated societies throughout history believed in the flat Earth theory. However, historian Jeffrey Burton Russell notes that with very few exceptions, no educated person in Western civilization from the 3rd century BC onwards believed that the Earth was flat. In fact, the idea of a round Earth appeared as early as the 6th century BC with Pythagoras, followed by Aristotle, Euclid, and Aristarchus, among others. Furthermore, the notion that many people, including Christopher Columbus, believed in a flat Earth was largely a fabrication of 19th century writers with anti-religious biases, such as Washington Irving and Jean Latrone. Despite this, the idea of a flat Earth continues to capture the imagination of some people, although it clearly contradicts scientific observations and theories. As James Davis notes, science proceeds by coming up with theories that explain observations, and simpler theories are generally preferred. The flat Earth model, on the other hand, begins with the assumption that the planet is planar and attempts to twist other observations to support this idea. While it may offer some odd explanations for individual phenomena, the model falls apart quickly when subjected to scientific scrutiny. If you enjoyed this video, don't forget to hit like and subscribe, and be sure to turn on bell notifications so you don't miss any videos, and we'll see you in the next one. Thanks for watching.